soil mainly, but also from plants, yes? And of course, absorption is zero in that time. So during the nighttime, any ecosystem all over the world is an emitter of CO2. But then we have the daytime, temperature is increasing, the breathing of plants increase also, but then we have the second flux. That's the absorption of CO2, what more or less we call it photosynthesis, yes? So if you put everything together, in fact, what we can do mitigating the climate is a play between photosynthesis and respiration. If we're managing our ecosystem in an appropriate way, we have a chance to mitigate climate by certain way. Why forests are so important, that's clear. 30% of terrestrial ecosystem at our planet is a forest, yes? And I show you a very short movie about this. How do people care about forests doing research all over the world? And this movie is from NOAA, and it takes about 10 minutes, but it's only 20 seconds from, or maybe 30 seconds from that movie. This concentration of CO2 last 50 years, it goes up. But these dots here are sites like Tuchno, where we make measurements, and here you can see the increase of CO2. That's the distribution of all sites all over the world. You see some places are not under control. Yes, countries are poor, they don't have money. This is very expensive. These are very expensive investigation. This map can be seen like this. That's from 2013. We had in that time 547 sites. Now, thanks to European project and American project like NASA and NOAA paid a lot for this. In Europe, ICOS, Integrated Carbon Observation System. That's the distribution of all sites all over the world. And this green, we are here. That's Tuchno site. We are in the international community database for the investigation all over the world. You can see how it grows. During the first site was established at Harvard University. Then there was a big American project, Various, and then the sites cover almost all continents. You can always you can even see the financial crisis 2008. These investigations are pretty expensive. So when we were in crisis 2008, 2010, there was also a decrease of new towers all over the world. Yes. In that time, luckily, in that time, thanks to Minister ŻYWO, we started this investigation in Poland. That's this site worked from 2008, exactly when we had this big crisis. Yes. And a small summary. What do we know? We don't know too much, by the way, but we know if you divide all forests on this planet, rainforest, boreal forest, and the temperate forest where we are, you can see that a forest can absorb from 18 to 22 tons every hectare of the forest of CO2. On the other hand, you have boreal forest with a short vegetation season and low temperature, so it's from 2 to 12. But this is a crucial point, because this kind of forest, like European forests, for example, or North American forests, they can absorb, if we could manage them, 21 tons. It's the same, almost the same amount like rainforest. And of course, to come to this conclusion, we need science. And this method we use here at the site, it's called eddy covariance. It's just pure physics, so it's probably boring for you. But I give you a very short example. How does it work? Yes, we have a tower. We have a sensor. This is funny because with one sensor we can observe thousands of hectares. Depends on the wind speed. And one of my PhD students during his defense, she made this picture, and it's very simple, and I think everybody can understand it. If we stop the time, like now, we have 6 particles of CO2 in the atmosphere and 2 in the forest, yes? So now I start time, I send a wind, and the wind will change everything. And now I stop the time again, yes? And now we had 6 to 2, now we have 4 to 4. We just observed the photosynthesis. 2 of particles were absorbed by the forest. More or less, that's the way how Eddie Corian's method works. The only problem is that we have to sample to create our database 20 times per second. That's difficult to imagine, yes? 20 times per second, every sensor is collecting data. So per day, we have billions of them. And traditional method to analyze it's impossible. So in my team, I have people who are really good in computer. I have no idea how do they do it. Yes, I have to trust them because they have big programs to do it. And on the final results, we get every half an hour how much CO2 was absorbed by this forest. So that's the history. That's the first tower built by human being, I can say, because this method was developed in 1856 by a mathematician. His name was Reynolds, a Britishman. But it was impossible to use it because we had no computers and we had no sensor which could measure temperature 20 times per second. So we had to wait more than 100 years, and people at Harvard University, sorry, that not at my university, they developed how to do it, and now it's almost a standard method. And now a short history of our investigation in Poland. Me and my team, almost everybody from my team, spent some time in Canada, University of British Columbia, where it's one of the best teams in the world, led by Professor Andy Black, who is a guru in Eddie Corian's. And that was the beginning. 94, I was the first time there. 97, I was climbing the tower. The tower in Canada is higher than here. And then 2001, thanks to Minister of Science in Poland, we got the first project with big money, like in Poland. So we could buy the first equipment in Poland. We made common investigation. And then from 2003 to 2014, we established 5 sites in Poland. The first one was at the wetland, not far away from here. The second was Tuczno, where we are. The third was thanks to European project Agriculture Land, and 2 new one, which I will talk about a little bit, also forest. And the whole work, mainly with Director General of Polish Forest and the Ministry of Environment, and thanks to them we can continue this measurement. And for those who are not going to climb the tower, because if somebody would like to go there, that's a nice view, a lot of equipment, but to give you an impression how it is there on the very top of the tower, we made quite a lot of programs here. Education is important for us, and one of the programs was made by BBC. That was for the climate conference in Copenhagen a couple of years ago, and it was 26 minutes, but I cut only 3 of them, okay? So don't afraid with 26 minutes, so you can see how it works.
Research and discovery. Futurists.
We know we should and we have to take an action to reduce the negative effect of climate change.
Professor Janet Solernik is one of Europe's leading specialists in climate change, and 25 years of field research worldwide has convinced him that action is urgently required. He takes us on a short tour to see what scientists are doing in different European research projects as they work towards understanding climate change.
Janus's latest project is a 40-meter tower deep in the woods.
There was minus 20 degrees that day when we recorded this movie.
Like many other countries in Northern and Central Europe, Poland has vast stretches of evergreen forest which need to be monitored in order to build up an inclusive picture.
So Tuczno Forest is the second site in Poland where we measure CO2 fluxes, the exchange between the ecosystem and the atmosphere.
That's a nice
For
view from
forests
the top.
again, the figures depend on many variables. For example, young forests actually emit carbon, while mature forests are carbon sinks or storehouses. The Polish team, based in the city of Poznan, are now fine-tuning a new instrument due to be deployed in the peat bog and forest.
And there was 25 minutes of this movie, what we are doing, not only in Poland. I was involved in 7 European projects, so we were traveling a lot. And it was funny because I asked the Euronews how many people could see that movie, and they said me about 30 millions, because it was 1 week, twice a day, yes? Wow. So that was pretty good. And some results, I prepared yesterday to show you how does the forest here, where we are work. This is 0. If the curve is below 0, means the forest is emitting CO2. If it's above, absorbing. And we have 7 years of investigation, and you can see that's a huge variability. The best year was 2009. And can you imagine that 1 hectare of the forest absorbed in this year 24 tons of CO2. But then we have 2015. There was a really bad year in Poland 2 years ago because there was a huge reduction of precipitation. There was almost 60 days with no 1 drop of water. So the forest forget about the absorption. They start to think how to survive instead of absorbing CO2. So the variation is 100%, and that's one of the reasons that we have to continue this kind of investigation at least 15 to 25 years. That's a standard. That's the period where after which we can say we start to understand what's going on here. And another problem what we have here, which we try also to solve, is extreme weather conditions, events like hurricanes. We had in Europe, I know you're not from Europe, so probably you never heard about it, but we had 3 or 4 events in Europe which destroyed huge areas of forest. Number 1 is Lothar in '99. That's French, Germany, Sweden and Italy, and about 30%, the total reduction of absorption in Europe was about 30%, thanks to 2 days of wind. Another example is coming from Poland, north of Poland. 2.5 million cubic meters of wood were destroyed. We lost it. But it was nothing. It was huge from Polish point of view, but it was nothing in comparison what's happened a few years later in Sweden. Gudrun, 27 hours, destroyed 75 millions of cubic meters of wood. That was disaster. That's the amount of wood which is produced in Sweden by 1 year. And luckily, because we are still in touch with people from Environment Ministry and people from Forest Administration. 4 years ago, something similar happened in Poland, not such a big, luckily, and it's Trzepciny Forest. And there are the 2 new towers we established there. And I show you now 1 minute movie again, how it happened and what we are doing there, because it's impossible to visit the site. It's more than 100 kilometers from here. And this is one of my students giving this presentation. This is not Kansas, this is Poland. Luckily there was only 25 minutes. but 500 hectares of forest was destroyed. That 7-kilometer pass where we built 2 sites similar to this tower. There was half a later when they start to recultivate the forest.
Where is the biomass from the 21 side?
The whole biomass was pulled out.
Welcome to the 21 station. It's operated since March 2013 and it was set up about half a year after tornado. What we have here is the eddy covariance system and the enclosed path and a lot of meteorological sensors. We do also chamber measurements.
And that's the second site. We didn't move the biomass, so it stayed like it was. They just pull out of the big trees and the rest by handmade, how to say, recultivation of new trees. Yes.
Welcome to my site, Plain Second. You can see exactly the same setup as in the Plain 1 site, except for additional overpass analyzer. Plain Second site
This is important.
About 2 kilometers from the nearest village. That's why we use our own tree.
When people see hear radiation, they always think Chernobyl. Yes, we didn't add sun radiation, and we have no visitors. The same plate is here on that side. Yes. And that just gives you the impression how people can change the CO2 absorption and how extreme weather conditions changes. This is Tuchno again. You see huge absorption, and in Szczecin it was exactly, we were lucky, this same forest, 70 years old pine forest, and after 20 minutes it changed into a source of CO2, and it still is. But luckily, not so bad. That was the first year after tornado, the second, and we are closer to zero. And we established a special program to calculate this. So we assume that this September, Szczecin forest went back to be a sink of CO2 instead a source. Yes. Unfortunately, if you compare these 2 sites, you see that if you leave a lot of biomass, the biomass, thanks to decomposition process, is emitting all the time. So our calculations show that Szczecin forest, the first one, will be zero September this year, and the other side in 2029. There will be such a long time emitter of CO2. So that gives you the impression how we, by appropriate management, can change the play between absorption and emission of CO2. And the final, our long-term goal is to have the same results. This is from Canada, unfortunately not from Poland. That's what we call chronosequences. It's the age 0, that's age 60 years. And you see at the beginning, this below 0, the forest emits CO2. But in Canada, it's around 15 years. It's back to be a sink of CO2. And we work on this curve, and I believe in about 10 years, Poland can present something similar, because it's important, because then we can create a model and to say something about the whole country, not only about one site. Yes? It is really important. Why? Because if we assume, which is more or less the truth, 15 tons of CO2 absorbed by a forest, 1 hectare, it's equivalent of a car driving twice around the world. So if you compare a car with 1 hectare of forest, it gives you the impression how important this ecosystem is in climate mitigation. And do we care about forest general on this planet? Well, I'm not quite sure. Look at this short presentation. That's closer to your country. That's Brazil. Yes? 25 years. The red color coming here, it's so-called clear cut. Yes? And this is area 300 by 300 kilometers. So clear cut destroyed because of economical reason, destroyed the forest. But I have also a good message for you. And the good message is coming from Poland. Poland, before the Second World War, we had 38% of forest here. Twice the front line was here, yes? The 39 Germany, 45 the Russian army. And we lost half of our forest. And that was 45. This data are from 2010, and I can announce that this year we will have 30%. So it's really, really good. Yes, this is certainly, Susan, I'm really proud of this. Wherever I am in the world, I show this picture. There are some countries that really care about forests. And education is the second. We are doing this kind of presentation everywhere we can, and we hope that our presentation influence the knowledge about forest. Sometimes the education is not so good. I give you one example. I got from my colleagues from Sweden. There was a test of ecology made by people working in a forest. Yes, and the question was, what can you tell about a tree when you see its annual rings? You know, how old is the tree as the rings show it, and you can say a lot about CO2, by the way, using new methods. But the answer, I think this course was not the best, because the answer was like this. You can tell that it's not going to get older. Yes, this is true, but I think that was not the goal of this. And my last message to you is the future. Yes, I'm afraid this is not a good message, because the climate, the change of the climate, the temperature rise. But this is not the worst information. The worst information is the variation. That even the climate will be warmer, we can expect really cold winter, or we can expect extremely warm summer. That's the variation. That's typical for changing the climate. And last two slides are related to this. This picture was presented by NASA in 2015, and the scientists agreed at the time that was the warmest year in the history of meteorological observations. And I use it also for my students. But this picture next year was not valid anymore, because 2015 was the hottest year. But I can ask everybody a kind of a question, how it is with climate and meteorology. Do you remember what did you eat last Wednesday? I don't think so. Yes? But do you remember, did you like ice cream when you were a teenager? I don't know if you like, but at least you remember, yes or not. And it's exactly the same with meteorology and climatology. We don't remember quite well what was the weather a month ago, but we remember cold winter when we were young, let's say, yes? And this movie shows you what's happened on this planet on, this is 1 minute, what's happened in 2015.
It's not in your mind. 2015 was the hottest year humans have ever recorded, thanks to climate change and a strong El Nino. Let's rewind and see what happened. In February, Arctic sea ice cover reaches its maximum extent for the year. It's the lowest ever recorded at 5.6 million square miles. A little while later, wildfire season starts in the US, and it's one for the records. Before the end of the year, nearly 10 million acres are burned. Overseas, Europe and Asia are blasted by heat. Melted roads and thousands of deaths in India and Pakistan.
I
As
still
summer goes
remember
on
the
in Germany,
summer.
temperatures reach an all-time high of 104.5 degrees Fahrenheit. In Iran, temperatures top 122 degrees. Combined with humidity, the quote real field temperature hits 163. One of the most extreme readings ever recorded in the world. Back in the US, California's snowpack hits a record low as a result of the ongoing drought. The fall sees storms and floods inundate cities around the world. South Carolina is swamped by a 1 in 9,000 year flood. 19 people die. Hurricane Patricia's ferocious 200-mile-per-hour winds whip the coast of Central America. It's the most powerful hurricane ever measured. In the Middle East in November, Cyclone Chapala bashes Yemen, a storm system extremely rare in that part of the world. Floods paralyzed Baghdad, and in India, killed almost 400 people in Chennai. In the U.S., Hurricane Sandra leaves at least 14 dead in Oklahoma and Texas. And in December, Storm Desmond devastates cities across the UK. While Ethiopia's government increased urgent calls for help, as the year-long drought there put more than 10 million people in peril. Heading into 2016, scientists say the more CO2 we put in the air, the more extreme weather events we'll get, and the more records will be broken.
And this movie, we are waiting for the movie from 2016 because 2015 is not anymore the hottest year in the year. Yes, but of course, I don't personally believe in a huge reduction in CO2 emission. Therefore, I'm a fan of sustainable development, really by being smart, managing in an appropriate way forest, and thinking about sustainable development all the time, like we do in Poland. I think so. It's probably a solution, and that's a good message. And in this moment, I would like to finish my lecture and thank you very much for your attention. My pleasure.
Great, great.